Hello and welcome to the session. In this session, we will discuss how to find probabilities using normal distribution. To find probability using normal distribution means to find the probability the random variable x will fall in a given interval. We can find probabilities like probability of random variable x less than equal to x. To find probabilities using normal distribution, we will follow the following steps. The first step is to convert the normal random variable x into the standard normal variable z using the formula z equal to x minus mu upon sigma, where mu is the mean of normal distribution and sigma is the standard deviation. So we have z is the standard normal variate, that is, its mean is 0 and standard deviation of variance is 1. Now, the second step is to draw the standard normal curve and plot the corresponding z value. The third step is to shade the required area under the curve. After this, the next step will be to see the value from the standard normal table. Let us now discuss the standard normal table and finding probabilities using it. The standard normal table is given in rows and column form. The table lists the cumulative probabilities under the standard normal curve, usually to the left of z. These probabilities are calculation of area under normal curve from the starting point to z. With this table, we can find phi z equal to probability of random variable z less than equal to z. For example, if we want to find phi of 1.45 equal to probability of z less than equal to 1.45. So, we first plot z is equal to 1.45 on the horizontal axis of the standard normal curve. It will lie to the right of 0. Now, our next step is to shade the required area under the curve. So, we shade the region of z less than equal to 1.45. It will be the area to the left of z. Now see this curve given here. This shows the table entry for z under the standard normal curve to the left of Z. Now, the Z value is 1.45. So, we find 1.4 in the left column. Then, we move across this row to the column 0.05 and there we find the value 0.9265. So, the area to the left of Z is equal to 1.45 is 0.9265. That means probability of Z less than equal to 1.45 is equal to 0.9265. So here are some guidelines for finding probabilities under standard normal curve. To find the area or probability to the left of Z, find the area that corresponds to Z in the standard normal table. Like in the above example, the area to the left of Z is equal to 1.45 is 0.9265, which is shown in the area shaded. Now to find the area or probability to the right of Z, that is probability of random variable Z greater than equal to Z, we use the result probability of random variable Z greater than equal to Z is equal to 1 minus probability of random variable Z less than Z. For example, if we want to find the probability of random variable Z greater than equal to 1.45, we shall use this result and we will get probability of random variable Z greater than equal to 1.45, which is equal to 1 minus probability of Z less than 1.45. So this will be equal to 1 minus 0.9265, which is equal to 0.0735. We subtract from 1 because the total area under the curve is equal to 1. So, the area to the right of Z equal to 1.45, that is, the probability of Z greater than equal to 1.45 is equal to the whole area minus the area to the left of Z equal to 1.45, which is equal to 1 minus 0.9265. Now, to find the area or probability between two Z values, that is, probability of Z1 less than equal to random variable Z less than equal to Z2, we use the result the probability of random variable Z lying between Z1 and Z2 is equal to probability of random variable Z less than equal to Z2 minus probability of random variable Z less than equal to Z1. For example, if we want to find the probability of random variable Z lying between 1.20 and 2.34, we use this result and we get this is equal to probability of random variable Z less than equal to 2.34 minus probability of random variable Z less than equal to 1.20. Now, from the table we can see that the value for probability of Z less than equal to 2.34 will be 0.9904 and the value for probability of random variable z less than equal to 1.20 will be 0.8849. So this becomes 0.9904 minus 0.8849, which is equal to 0.1055. If the table does not give values for negative value of z, we need to find the area or probability for negative value of z. That is, probability of random variable z less than equal to minus z, we use the result. Probability of random variable z less than equal to minus z is equal to 1 minus probability of z less than equal to z. The result is deduced from symmetric property of the curve. For example, to find the probability of random variable z less than equal to minus 1.45, let us plot it on the normal curve and shade the required region. Now, we plot z is equal to minus 1.45 and plot z is equal to 1.45 on the same curve. Now see by symmetry, area lying to the left of z is equal to minus 1.45 is equal to the area lying on the right of z is equal to 1.45. That is, probability of random variable z less than equal to minus 1.45 is equal to probability of random variable z greater than equal to 1.45. We know that probability of random variable z greater than equal to z is equal to 1 minus probability of random variable z less than equal to z. So we have probability of random variable z greater than equal to 1.45 is equal to 1 minus probability of random variable z less than equal to 1.45. Thus, probability of z less than equal to minus 1.45 is equal to 1 minus probability of z less than equal to 1.45, which is equal to 1 minus 0.9265, which is equal to 0.0735. Similarly, probability of random variable z greater than equal to minus z is equal to probability of random variable z less than equal to z by symmetry. We shall also note that probability of random variable z greater than equal to 0 is equal to 0.5 and probability of random variable z less than equal to 0 is equal to 0.5. So in this session we have discussed the use of normal distribution to find probabilities. This completes our session. Hope you enjoyed the session.